In earlier class, we discussed about the probability theory. The probability theory, addition theorem for two events. So in this class, we are going to discuss about the random variable. Before going to discuss about the subjective type questions, you may recall that what is the random variable. So what is the random variable? First, a random variable is follows. See, a random variable is a real number associated with all possible outcomes is called a random variable. For example, if I am tossing a coin, the sample space S equal to H, T, then possible samples HT, TH, TT and HT. So this is the possible outcomes. In the possible outcomes, I am associating a real number. That is, that event I am defining. What's the event I am defining here? Happening of head. Happening. How many head here? One head. Then one head here. One head. Triple T. Both are T. This is two tail to no head. Here one head. So two. See, a possible outcomes in a real number we are associating a possible outcome is, that is, here no head, here one head, here two heads. Okay, so there is here possible, you know that possible is 2 to the power of 2 equal to 4 possible. In that 4 possible, here no head, one head, both are head. Okay, so what are the real number? What are random variables? 0, 1, 2. So this is called the random variable. Okay, so what's the meaning of the random variable? Says a random experiment is conducted, that is tossing a coin. In that while tossing a coin, we are getting the possible outcomes, 4 possible outcomes. In the 4 possible outcomes, I am associating a real number. That what the event I am defining? The event I am defining is happening of the event head, happening of head. So there is no head, one head, two heads. So this is called a random variable. Okay. After that random variable, there is two cases. What is the discrete random variable and the continuous random variable. In the discrete random variable and the continuous random variable, then there is the properties of the expectation. This is equal to summation of x into p of x. Then continuous random variable integral of x into f of x into dx. So based on this, we are going to discuss about today. This is not only the definition, then the properties of the expectation, properties of the variance, then Chebyshev inequality. These are all the topics what we are going to discuss about in the random variable. The next class we will discuss about the bivariate random variable. The related TNPSC questions, how they will ask that question. For example, when x is a discrete random variable, then which one of the following statement is not a correct? Suppose you must learn about you must understand what do you mean by discrete random variable. They are giving that what's the question is very important is which is the following statement is not correct. Okay, so x this is a discrete random variable. X can take finite number of values. So this is the x can take finite number of variables. This is a discrete case. Okay, the number of possible values x can be countably infinite. This is also discrete. X can take on any value within a finite interval. This is also discrete random. So that indirectly they are asking, do you know the meaning of the continuous random variable? So the number of possible value of x can be at most countable. This is the correct answer. So this is the possibilities for the correct answer. At most discrete. So for example, what is here at most discrete? 0, 1, 2. So therefore the discrete random variable is 3. So this is called the discrete random variable. So then the height of a father and a son is form a bivariate random variable. This is the case of the bivariate random variable. The bivariate random variable f of x, y. The f of x, y. X is father and the y is the son age. Then you will know about the bivariate random variable, that f of x comma y, integral double integral dx into dy. You have to find out the marginal distribution of x and the conditional distribution of x given y, joint distribution, marginal distribution. Then we will discuss in the next session. So, but this is only that example. You take that bivariate random variable, son and father variable will continuously random variable. Is it not? So this is called the continuous random. So these two examples discuss about the what do you mean by discrete random variable, what do you know, what is the meaning of the continuous random variable. The question will be asked like that only, or you have the knowledge about the what's the meaning of the discrete random variable, what is the meaning of the discrete random variable, and the example as well as some properties also they will be asked. Okay. Then what do you mean by cumulative distribution function? Cumulative distribution function is that that is f of x equal to p of x less than or equal to x. Okay, so this is the definition of the cumulative distribution. So there is a properties always that non-increasing, this is always a non-decreasing, right continuous, f of minus infinity equal to 0, f of plus infinity equal to 1. So you have to, before to answer this question, you have to recall that what do you mean by definition of the cumulative distribution function. That other name is called the cumulative distribution function. Its properties, it's always non-decreasing function, right continuous, f of minus infinity plus infinity equal to 0, f of plus infinity equal to 1. So these are all the properties of the cumulative distribution function. So based on that property, they are asking one question: if f is the distribution function of a random variable x, if a is less than b, then probability of x a less than lies between a to b is equivalent to f of b minus f of a, f of b minus f of a. You studied in that. These are some problems also asked in that UG level. 2 more questions. Okay, you applied that value will be given upper limit minus lower limit of the cumulative distribution. Then what do you mean by variance? You know the variance of x squared into f of x into variance of x equal to expectation of x squared minus expectation of x whole square. Expectation of x squared minus expectation of x whole square. So this is the relation between the raw moments and the central moment. You know that raw moments is deviation from the 0, that is equal to expectation of x minus 0, then expectation of x equal to c. This is a constant. So using these properties of the expectation and the properties of variance, there some problems will be asked. Suppose you have to recall that what is the property of the variance of the cx. That variance of cx equal to c squared into variance of x, and the variance of constant equal to 0. So these are the properties of the variance. Then using that, they are asking the one question: if variance of x equal to 1, that is given, variance of x equal to 1, variance of 2x plus 3, how to apply this principle? So you have to recall variance of cx equal to c squared into variance of x. So you apply here c squared into variance of x plus variance of constant, that is 4 into variance of x plus 0. Then variance of x 4 into variance of this is equal to given variance of x is given, that is equal to 1. Therefore 4 into 1 equal to 1 4 0. Therefore this is the variance of what is the question asked, variance of x equal to 1, then variance of 2x plus 3. Find the variance of x, that variance of x equal to 4. So variance of x equal to cx equal to 4. So this is the answer. Then instead of, sometimes the problem may be asked using the property you all recall. Sometimes directly they may ask that variance of, if y equal to cx, c being a constant, then expectation of y equal to 0, expectation of y equal to c into expectation of x. This is the property. Then using the same, some problem they are given, let x be a random variable with the following probability: x equal to minus 3, 6, 9. Probability value is given. So this is called the discrete random variable probability mass function. For the discrete random variable, that is called the probability mass function. For the continuous random variable, that is called the probability density function. Then minus 3, 6, 9, 1 by 6, 1 by 2, 1 by 3. Then they find the value of expectation of x. Then formula: expectation of x equal to summation of x p of x. Then substitute summation of x into p of x equal to minus 3 into 1 by 6 plus 6 into 1 by 2, 9 into 1 by 3. If you substitute, you are getting the value of 11 by 2. So this is the example for applying the properties of the expectation. So today we discuss about the what do you mean by the random variable. Random variable is a real number associated with all possible outcome is called a random variable. There is two types of random variables. One is the discrete random variable, another one is the continuous random variable. And using the properties of the discrete random variable, we have seen that some few examples related to the Tamil Nadu TNPSC Public Service Commission they are asking. Okay, so you have to recall that next class I will continue about the bivariate random variable. In that bivariate random variable, then probability generating function, moment generating function, characteristics function, Chebyshev inequality. So with that probability theory is 5 components I subdivided. First component is a probability theory we discussed in the earlier video, and today this session I discuss about the random variables, few example problems. Then hereafter I will discuss about the related TNPSC problems worked out, and then I will show that the theory materials I will give you that very shortly. Regarding it, what I covered, I will send that objective type question, you have to answer and send me. Thank you. If there is any doubt, you can ask me.